Right. Now, this is the course that I will be teaching for you, Introduction to Astrophysics and Cosmology. And the course code is PHY305G2. And I guess you know about these details, right? And this is taken from your website. So you have 30 lecture hours, and you can see here something called independent learning. So which means I expect that you will at least spend around 70 hours out of the class by studying yourself, right? So that means any homeworks, any tutorials, and any assignments that I will be assigning, plus whatever we are learning in the course, right? And so I assume that this may be the first course in astronomy that you are doing in your university degree. And so the objective of the course is recall the historical developments of astrophysics. So that means you just give a brief idea about what kind of history behind this subject, and then just demonstrate the basic physical laws, explain the properties of and dynamics of astronomical objects. And what that means is, like, for example, if you look at the motion of the planets, you can basically explain those motions using Kepler's laws, right? So we will be kind of try to learn some of these laws and see how we can apply these laws to explain the motion of these planets and those kind of things. And of course, we will learn about the properties of solar system, which means some details about our planet and other planets in our solar system, and then about stars and galaxies. Basically, when we learn an astronomy course, you have to learn about stars, planets, and galaxies. So that's what we will be spending most of our time. And then at the end, we will also look at the origin and the evolution of the universe. So that means we will try to understand how the universe began initially and how it has evolved up to what we are seeing right now, right? And so by the end of this particular course, so this is what I expect that you should know, right? So this is what will be tested for you. So to make it clear, right, even in an exam. So that means there are certain learning outcomes that I have mentioned here. So that is explain the physics of telescopes, including geometric optics. So that means you have to, you should be, because there will be a section about telescopes in one of these lectures. So which means at the end of the day, you should be able to explain the basic physics behind these telescopes, right? How the telescope works and how you can see these distance objects through a telescope, those kind of things. And then you should be able to explain how astronomical distances are measured. And that's because the distances, the distances that we are measuring in astronomy is completely different what you used to measure on Earth, because you know that for example, if you need to know the distance to a particular city or even for a particular country, you used to use kilometers or miles here, right? But in astronomy, we don't use kilometers and miles because the distances are so huge. And if you use kilometers and miles, the numbers you will get like huge numbers. And because of that, the set of units that we are going to use in astronomy is completely different what you will be using in your day-to-day life. Now this is why we will be learning about how to measure the distances and what kind of units that we will be used for that you will be using. And the other thing is the measuring distances. Now the measuring distances, you can use in your day-to-day life. You are going to use like a meter ruler, and there are other well-known methods that you can measure distances on Earth, right? Now the problem or the challenge in astronomy is you can't reach to the other end, right? For example, if you need to measure a distance to a particular planet, there is no way that you can, reach to that planet. So we have to use completely different techniques to measure distances in astronomy. So that will be interesting for us to learn about that. So we will be learning about how these distances are measured. So what that means is in different stages of your course, I will be introducing, different methods that we will use to measure these distances in astronomy, right? So that is something that I expect from you at the end, that you should be able to explain some of these methods that we are going to use to measure distances. And the other thing is, as explained in the course objectives, you should be able to use, for example, Kepler's laws, and also, of course, the Newton's laws and other theorems to explain the dynamics or the motions of these different astrophysical objects. For example, you can even try to understand some more details about extrasolar planets or exoplanets. In other words, using some of the physics that we know. And and the other thing is you should be able to explain the global properties and basic evolution of stars. And this evolution of a star will be one of the major part that you will be, learning in this particular course, because evolution of a star is it's a completely different story. So it's like all of us have a story about how we were, how we come to our world, and then how we grow up, and then with the age what happened, and then at the end we will die, right? So the same story will apply for stars. So there is a mechanism for the birth of a star, and then based on initial properties of that star, we can actually explain what would happen to that particular star using different laws and different theories. So we will learn about those kind of things in this course. And also the next one is to understand about the structure of the Milky Way. So how the Milky Way is basically the galaxy that we are living. So we should actually know more details about our galaxy. So because of that, we will learn about structure of the Milky Way, how it is made of, what kind of basic properties that we can see in our Milky Way. And at the same time, we will learn about the other galaxies as well, right? And then if you go into the cosmological aspect of this course, or into the range of the cosmology, what we will learn is about the very fundamental constitutions of the universe. So that means how the universe is, what kind of things or fundamental particles that we have in the universe, right? How we are made up from those particles and those kind of things, and about the dark matter and the dark energy. For example, what is like dark matter, what is dark energy, and what is the difference between the dark matter and dark energy, and why these kind of things are important. So we will learn all these kind of things towards the latter part of your course. And so just to keep in mind, we are actually not going to go into too much details about these things, but I will give you a very basic introduction, right? So assuming that this is the first time that you are going to hear about these, kind of an interesting topics that we talk in astronomy. And then finally, we will talk about the Big Bang theory, which is the standard theory and mostly and widely accepted theory about the evolution of our universe. And so those are the things that I expect from you. So this is basically what I will be teaching, and this is what you will be tested at the end of this course, right? So what I'm going to test is that whether you have a knowledge in these areas, whether you can explain how a telescope works, like the basic physics laws, and how you can measure the distances, and how you can explain the evolution of stars, whether you can explain those, and then whether you know about the structure of a Milky Way, and those kind of things will be tested at the end, right? So this is right. In terms of the course content, if you go to the syllabus of this particular course, so we will talk about a little bit of history and the units that we are going to use in astronomy, and some of these measurement techniques, and the motion of these astronomical objects, and then about the celestial sphere, and how the stars are located in this sphere, and then about the telescopes, and some of the phenomena such as Doppler effect, those kind of things. And in the second part, we will learn about the solar system and exoplanets, and about eclipses like solar eclipse, lunar eclipses, and then different kind of planets, and also properties of the sun. So those kind of things we will learn in the second part. And then next we will move on to the properties of the stars, and how you can measure the properties of the stars, and how you classify stars based on their properties, and how to measure some of these properties of the stars, and how we can measure the distance to a star, and about the spectral classification of the star, and other relations like mass, density, those kind of things, right? Then you can see that we are going to, cover quite a lot in this particular course about stars, and then also about the Milky Way and galaxies, those kind of things. And then the last section will be about the cosmology. So the cosmology means we are going to talk about, the expansion of the universe, evolution of the universe, and there are some other specific diagrams like that I have mentioned here, and about the dark energy, and about the expansion of the universe, those kind of things, right? And and our basic teaching method will be, so I'll be delivering lectures like this, and at the same time, actually, I would like that you talk more in lectures, and if you have any questions, you can ask it from me at any time. And so, anyway, I will give you some time at the end of the lecture to ask any questions. And so I have been in this field now quite a bit of time, since like 2014. I have been doing astronomy for a long time now. So in case if you need to know anything, it doesn't need to be specifically about the lectures. If you need to know anything else, you are free to ask about any question, right? So I will try my best to answer those, and there will be tutorials for you, so you have to complete. And apart from this, sometimes I used to give you a few assignments, so those assignments will be mostly based on, like, you just go outside and look at the sky and see how the stars looks like observation kind of things, right? And in terms of assessing you, what this course has mentioned is like 30% of the marks will come from the assessment, and in for the final exam you will get 70%. However, this may change a little bit, so I have to discuss with about this with your department, since we are doing all the things online. And what has happened in last year is that we didn't have any space or any time to do these continuous assessments. So all the marks are kind of went into the final exam at the end. So for this time, I'm not. I do not actually know the condition of your university, whether you are completely doing everything physically or not. So I will check that with your department, and if in the usual case, you will be getting sometimes maybe a assessment which was like 30%. So I will talk that with your department and let you know. And there are some recommended references here for the course, and all of these are like different kind of books. However, I actually recommend a different book for you. So that book is called, it is actually an astronomy book, which is completely free and available online. So let me show you. I will give you the link for that as well. There is a website called OpenStax, if you don't know about it. And there are free books for any subject here, right? Even if you are, following a different subject, there may be a book that is relevant to you. So what I used to have is this astronomy book that they used to follow, and there is a second edition that that is here. And this book is, by the way, completely free. Anybody can download it and use it, and it's completely legal. Or you can, look at it online as well. And the book, so you can take the PDF if you need, and if you need, you can watch online as well. Now, most of my lectures are actually based on this particular book, and I have done it for a reason. The number one is this book is completely free. You can access it at any time without any cost. And the book is very comprehensive and written by a set of astronomers who are very, 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 very famous and very and well experienced astronomers. And also a book is a very basic one. And if you need, more details, you can go through completely. You just go and completely read the book. And most of my lectures will be based on this particular book. And let me just post this link for you. If anybody is interested, you can go and read this book. And there is an app if you are using a mobile phone, which is called actually OpenStax SE. So let me see. I can give that to you as well. So by the way, the today's lecture, there will be most of my time will go into give you these details and make it clear, like what I will be teaching for you and what kind of resources that I am using, right? And after that, we will start the lectures. Right, so you can see that there is an app called OpenStack Plus SE, and this app is available in both Google Play and also Apple Store. So you can download that app from any of these stores. And once you download the app, so this is the app. So let me just give you one link. You can probably should be able to find the other links. So the advantage is this app is also completely free. You can download it, and once you download, all these books are available inside the app store, so that you can go and look at all these books in the app store, right? I can read through the app store as well. So let me see and show you how it works. Yeah. That's right. And one thing is, when you try to log into this app, they will be asking from you about. Okay, so you said that you can't hear me clearly, right? So let me just check. how about now? Can all of you hear me clearly? Right, so just give me a minute so that I Hello. Is it still not clear or? Because I can see the, right. So it says now, okay. So I hope all of you can hear me now, right? So what I was explaining is there is this app called OpenStack Plus SE, which you can download for your mobile phone if you like. And once you download it, you can actually use this book from the app as well. That is also completely free, which will make it a lot easier for you in case if you do not have a computer with you, right? So you can see that the reason that I have selected this book is all of you will get some kind of access to the book. Right? So that's what I want, right? So that's about the resources that I am using and what kind of resources that you have to use. And now let me move on to our first lecture. And before that, I would actually let me show you one software, and you will actually see that I will be used talk about a lot of things that are out of the book and out of the lectures, which I feel that as students who are learning astronomy that you should have some kind of knowledge, right? And one thing that I would like to discuss with you today is how you can use these one of these softwares to look at the current sky and what kind of things that you can see in the sky, right? And there is a software called Stellarium. Maybe some of you have heard about it. And let me share that screen with you. Yeah. So I hope all of you can see my screen. And here is that particular software. And I have actually set up the settings to Colombo. And this is what you should see right now on the sky if you go outside. Right? For example, you can see this band right here is the Milky Way band that you should be able to see. And then here is the star Vega. And if you need to go and look at how it looks like in the morning, you can just use these buttons right here at the bottom. And I guess let me just switch off my video right now, right? Because it will make it a bit easier for you to listen to me. And so let me show you that. So this is how the sky looks like throughout the night, starting from night right now. And you can see that when it comes to come closer to midnight, the Milky Way band is coming right here. And here is the Saturn comes on, and Mars and Jupiter and which means you can see that around like 3 a.m., 3:30 a.m. in the morning, if you look at the eastward side, you can see there are three planets on these days. The Saturn is the first one, and the Mars and the Jupiter. And believe me, like if you are in a place that the skies are very dark, you should be able to see, all three planets from the naked eye as well. And if you have a smaller telescope, you can, easily see those three planets. But it has to be, a little bit darker. If you are, in Jaffna town, maybe, I don't know the condition because I have never been to Jaffna. And so, so I hope that if you are in a site where it's get really dark at night, you should see all these three planets like Saturn, Mars, and Jupiter. In like if you wake up in the morning, just look for these three planets on the eastern sky, and you will see that before the moon rises. Moon is the one that is rising up from the east side. You should see Saturn, Mars, and Jupiter, right? And I mean, these kind of things you should be able to, you should know about these things as students who are, following an astronomy course in the university. So other than about these lectures and everything, from time to time, I will show you these maps and explain you what kind of things that you should be able to see on the sky, right? And there may be, one or two like some exercises that I used to give for students, and these exercises also will, change from time to time because the sky changes. The sky is not the same in each and every day and each and every time that I am teaching, right? For example, when I was teaching last time, it was around, January, February. So then I used to discuss a lot with students about the Orion Nebula because when you are in the month of February, January, like in February, Orion constellation and Orion Nebula is right above your head around 7, 8 p.m. when I was teaching. So then I used to talk about that. But now I know that Orion Nebula is, a little bit down now. But what you can see now is these three planets, which was not available like, at the earlier time. Now, during the lectures, at some point, I will explain you how you can predict about this position, about the planets and these stars as well, right? Right. So I hope this will make it a little bit more interested for you. Right. So let me go back to, if anybody need like more details about, how I am using these softwares and everything, feel free to ask those things. So because I don't have time to like explain everything. Right. So the software is, one of you are asking the software, and this is called Stellarium. Let me give you the link so that you can download. Actually, there are some other softwares as well, but this is a kind of completely free software that works in all three operating systems. So it will be easier for anyone to use that. So you just download it, and then there is a, if you go into the lower left-hand section, there is a place that you can set your location and the country. And once you set it, automatically shows you the night sky, how it looks like tonight, right? So you can go and, locate any object using that particular, this particular software. And there is the version that I guess there is an app from the same software for the mobile phones as well. You can use that as well if you like. Right. And having said all these things, let me go into the very first lecture and try to get a starting point today, right? So after that, we will continue from the next day. And by the way, I normally don't like to drag these online lectures for a longer time. So most of the time it will be just for 1 hour. So I will do like 2 1-hour lectures, 2 1-hour lectures per week. And then it will go on to all 15 weeks, right? So that is the plan. But there may be time that I will have to cancel lectures for different reasons. And maybe I have to go like up to 1.5 hours like that. But what I try to do is just to restrict it for 1 hour only, right? And your lectures will be most of the time will take in this particular time, like 9 to 10 p.m. And that makes sense for astronomy because it's night time. So we should, everything happens in astronomy. Like most of the time, the things that we discuss is observable at night, right? So it is better to study astronomy at this time. So I don't see any problem of that as well. And now let me start the first PowerPoint presentation. So I will be doing PowerPoint presentations most of the time. And so let me I assume that all of you can see my PowerPoint presentation right now, right? If you cannot see, please let me know, right? Right. Now the course is Introduction to Astrophysics and Cosmology. And in the first chapter, or maybe in the first 2 days, I would like to uh, walk you through a brief tour of the universe, right? Because this is important that you get an overall picture about universe so that you can have a good idea about what we are talking about, right? Now, by the way, the image that you see here in my first slide is an image of a large telescope facility, which is this one right here. So there is a large telescope inside this with this huge dome. So this is how normally these large telescopes are working. And so basically this course about the astronomy will be like a series of voyages to explore the universe as astronomers understand it today, right? So basically we will look at uh, the universe in the way that astronomers understood it up to now, right? So that's what we are going to do throughout this course. And to start with, so I will start the course instead of talking about planets and everything. I'm going to show you 2 galaxies. And so just to give you an idea about what kind of dramatic things that are happening in this universe. Right? Now, when you look at this picture, this is uh, actually a picture taken from the Hubble Space Telescope. So I hope all of you have heard about this name, about the Hubble Space Telescope at a certain point in your life. In our time, in our school time, Hubble Space Telescope is, one of the big, big news in the media. But nowadays, Hubble is, spending its last few years on the space, taking photographs. Now this new telescope called James Webb Space Telescope is going to replace Hubble Space Telescope. And these are actually 2 galaxies that are interacting together, right? So that's what you can see in this particular picture. And this is a real one, which is taken from the Hubble Space Telescope. And what you can see is we are inside the galaxy, inside the solar system, inside the planet, and inside the planet in a certain location, right? But when you look at the outside universe, you can see these kind of things that are happening, like interactions between even galaxies, right? And now, with that image in your mind, so we can talk about why this field called astronomy has become a very exciting field for scientists. And you can see that in everywhere. If you start talking about astronomy, most of the students, like school students and everyone, get interested, right? Now, what actually made this interested is some of these very exciting discoveries that astronomers have made with the science and the technology that they have, right? So I have I list up some of these details. For example, one of the well-known thing for us is uh, craters that you can see in different parts of the earth, and plus other evidences on earth that tells us that there were dinosaurs in the past, and all these dinosaurs are died because of a cosmic collision. And we used to tell that this may be a huge meteor impact, right? I guess all of you probably have heard about this news at some particular point in your life, right? And then the other thing is, if you go into the moon, the gravity is so weak. And you probably have seen this Neil Armstrong, who is the first person to land on the moon. When you jump on the moon, it is completely how you feel is completely different compared to the Earth because of this low gravity, right? And as a result of that, if you throw a baseball, if you throw it hard, you can put it into orbit, right? And if I guess you are in the third year of studying the physics, and I assume that you probably have some understanding about the classical mechanics, right? Now, if you can throw it hard, you can actually put this baseball into an orbit from the moon. So that is because of this low gravity. And you can see that the things that you cannot see in the Earth, you can always experience those in the space, right? So that's why astronomy has become very one of the interesting fields to study. And on the other hand, if you think about the stars, as I have mentioned here, the collapsed star is so dense that to duplicate its interior, we would have to squeeze every human being on the Earth into a single raindrop. So that means these stars, we will talk about this in details in the future, but if you look at the stars, and when these stars collapse, the density will get huge, right? And if you need to compare it, so that is something similar to squeeze every human being on the Earth into a single raindrop. So you know what a single raindrop means, right? And if you can squeeze all the human beings on the Earth into one of these single raindrops, you can think about the density of that particular object, right? Now, so this is what would happen to these massive stars at the end, and we will call it as a black hole. And of course, we will learn about the black holes at some point in this course. And so those are the interesting things, and things and discoveries that we have made in astronomy, and this is why the astronomy has become such an interesting subject for everyone. And there are some two other important things that I have mentioned here, but I am not going to talk each and every step, each and every item, right? You can see here. Right, so some of the things that things that are very exciting in today's astronomy. Now this is, all of you know that this is an image of Mars, right? And you can see that the development of the technology here, and this is an image of Mars, which is one of the planets, probably one of the closest planets for us. And in this image, you can see that this Marina Valley asteroid right here. You can see that. If you let me get the pointer. So you can see here Valley asteroid, right, very clearly from Earth. And this is an image taken of the Mars. And what this mass mosaic means, actually the technology that they have used to construct these images is, so they used to use CCD cameras, and what you get different parts of this CCD of the mass to different chips of the CCD camera, and then you collect all those together to make this final image, right? And here is an image of, I would say, this is called remains of a star that have exploded, right? And this is called Crab Nebula, by the way. And so I'm not going to explain why these are important, because we will talk about nebulas in the future when we talk about, evolution, with different evolutionary stages of a star. Now, what you can see from all these, observations and things that I have shown you up to now is, astronomy is, completely different science when you compare to other sciences that you used to learn, right? Because we have to get the information about the cosmos from the messages that we receive from the universe, right? So there is no way that you can go into each and every object and check those, right? You know that's not going to happen. And so normally we have to collect the messages that are coming from different parts of the universe, and then depending on those messages we make predictions, and we get information from those messages to understand the universe. So that's what normally happens in astronomy. And so by the time that when you finish this course, you will also know a bit about how to read these messages that coming from different parts of the universe, right? So that's what I expect from you at the end, because you should be able to read these different messages coming from the universe and understand them, and then you should be able to predict something, right? So that's a part of this course as well. And astronomy is normally defined as the study of the objects that are beyond our Earth, right? Anything that we study beyond our Earth will be considered as studying astronomy, basically. And the other thing is, astronomy is actually an observational science. So what does that mean? So what that means is, if you just look at all the other sciences, you can do experiments in the lab, right? So you go to the lab and test the theories that using those equipments. But the astronomy is completely different in that sense, because in astronomy what we are doing is actually we observe things using telescopes and naked eye, different technologies. What we do is we observe things, and then based on the observations we make predictions, and we apply science, and we make decisions, and we come into conclusions, right? And that's how astronomy works. So that is why we called that astronomy is an observational science. And even in this introductory astronomy course, you will learn about objects and processes that no one in the few generations. What this means is, even this is a new astronomy, very introductory course, you will learn some of these objects and processes that we even not dreamed, like 10 to 20 years ago, right? For example, if you have seen in the news, like I guess 1 or 2 weeks ago, now we have images that we have imaged black holes now, right? So we have images of the black hole. So I will tell you those stories when it comes, which are things actually nobody have imagined, like 10 to 20 years ago, right? And if you connect the astronomy again with the scientific laws, normally these scientific laws are the rules that excuse me, these are actually the rules of the game that the nature plays. So that's what we normally used to tell. So we have these observational science, which means we can't change it. So what we see is what we considered as the things that we observe, and then we are going to apply these scientific laws to explain those observations, right? So that's what we are going to do most of the time in astronomy. And basically these laws apply, in everywhere in the universe. And right, so this is a kind of a very basic introduction about, this subject, what we are going to do with, all these lectures in future. So we will discuss different topics, and we will look at what we can observe under that topics, and based on the observations we explain the science behind that and then make conclusions, right? So that's how the astronomy is connected with science. Now remember that I told you about the units that we are going to use in astronomy. We normally used to deal with a different kind of units in astronomy. Now if you look at the distances that we are looking at, the distances that we are talking in astronomy is something that you probably have never taught before in any other courses, because these distances are very huge. You cannot use kilometers. And because of that, the first basic unit that we are going to introduce is the light year. You probably have heard about that. Now, if you look at the relationship between light year and kilometers, as I have mentioned here, the 1 light year is equal to 9.46 times 10 to the power 12 kilometers, right? By the way, you don't, I mean, it is better that if you can remember these kind of relationships, because you can convert it in back and forth whenever you need, but you don't have to, right? In an exam, I'm going to give these conversions. And now, why we use light years instead of kilometers is that even if you think about the nearest star, right, for us, it is actually 4.3 light years away. So this is more than 40 trillion kilometers, right? So you can see the amount of distance that we are looking at. And even the nearest star, when you need to talk about the nearest star, you can see that it's around 4.3 light years away from us. Now, this is why we cannot use, or we don't use kilometers, and why we are using the units like light years, right? So that is the first thing that you have to understand in astronomy. And here is an image of the Orion Nebula, by the way. Orion Nebula is normally located in the constellation Orion. And if any of you know a little bit about astronomy, you probably have heard about, Orion Nebula and the Orion constellation, which is one of the most popular constellations. And a nebula means, it's kind of a place that it's kind of a nursery for the formation of stars, right? So that's how you define it. And this nebula, when you take pictures of this Orion Nebula, it seems to be one of the beautiful places that you can see. And normally it's located inside this Orion constellation, right? And once again, from my experience, I can say that if you are in a really dark place around, February, March, and April as well, around 7 to 8 p.m., if you go outside, you should be able to see the Orion Nebula very easily. And then inside the Orion Nebula, Orion constellation, inside the Orion constellation, you should be able to see this Orion Nebula very easily. But to observe the Orion Nebula from the naked eye, it has to be really dark. Right? Otherwise, you cannot see it. The sky has to be very clear as well. Right. Now, let's see when we do observations in astronomy, so we have to consider about the consequence of this light travel time. So that means when you say something like, let's say 500 light years away, what that means is if you are looking at an object or a star that is 500 light years away, what that means is actually that you are getting a signal that is 500 years old, right? Because light takes some time to travel from one place to another place, and you don't feel it that much, this particular effect on Earth, because the distances that we are talking is very, very smaller. So even though light takes time to travel from one place to the other, you don't feel it that much, right? But when you talk about large distances like this, for example, 500 light years, if there is a star that is 500 light years away, what that means is you are looking at a star right now, which is 500 light years away. So which means that the time it has taken for this light signal to reach us is 500 years, right? So which means when you look at it right now, what you see is how that particular star looks like 500 years ago, not how it looks like now, right? Now, this is very important to keep it in mind when you study about astronomy, when you study astronomy and astrophysics, right? So this is something that we cannot avoid. So there are, but advantages of that as well, right? So let me stop from here for today. And anybody have any questions up here? Please feel free to ask. There are 2 or 3 to 10. So please feel free to ask any questions. And so if you have any questions, please feel free to ask. If you do not have, just few things, and if there are any other students who have not joined today, please pass the message to them that make sure that they are in these live lectures. I used to record the lectures, and then but sometimes in these live lessons there are instances that I couldn't record, and because of that I recommend that all of you be in the lecture, and there may be some sessions that I do interactively with you as well, right? So that counts, accidentally. I can't tell it, I am going to do this session. So because of that, it is always very, very easy for you to follow if you have joined with these live sessions, and it will be more helpful actually. And depending on how the lectures go, there may be, I used to give sometimes, questions for students to answer in the real time, and I used to get recorded, and that those may be used, for evaluations at the end. I will let you know about that at the time when this happens. But just ask others if there are anyone, that just make sure that they join with the lectures. And there is a question that one of you have asked, that will you upload these notes through a PDF file? The answer is yes. I'm going to upload these through PDF files. So you will see all these notes in the Google Classroom as well. Right? Right. Any other question? Oh, by the way, there is something extra that we have been actually developing a small proposal for your university about with the a network of telescopes called LCO telescope network. And this is actually give a few of the undergraduate students a little bit of exposure to basic research in astronomy, which means you will get telescope time in from set of telescopes in this LCO telescope network from a foreign university, and some of you may get. I mean, you will get this message from the head of the department in future if the proposal get accepted, right? So we used to, as a group, we are going to write a small proposal for that, and that's something extra that I'm doing with your university. Right. So if any of you do not have questions, let me stop from here. And so these lectures are always going to be very exciting from day to day, right? And keep in mind that I am sometimes I use the same slides from the previous years, and sometimes not. For example, these slides, these lectures are new, which I didn't do, last year. So I used to change some of those. So just to let you know, and I mean, there is always something exciting in each and every day, in these astronomy lectures, right? So make sure that you participate all these lectures, and if something is not clear, you can make it clear at the end. So I will give you time. Even outside the class, if you have any questions, please feel free to contact me at any time, right? Or if you feel that if there is something not clear that I have told in the previous day, and if you need to make it clear again, make sure that you just drop me an email or just send me a WhatsApp message telling that this part is not clear, whether you need me to explain it again. So that's fine for me, right? So just let me know, I will re-explain those. Right, so if you don't have questions, let me stop from here, and good night to everyone, and we will meet again on this Friday. Sorry, not this Friday, on next Monday, right? So the plan is to conduct these lectures in every Monday and Wednesday at 9 p.m. Right? So the next lecture will be on next Monday, right? Right. Thank you and good night.